All right, section 10.1 is where we're headed today. Let me just give you a bit of a motivational speech about section 10.1, okay? Did you guys, help me out, did you guys take a geometry class? I think I asked you that before, I just couldn't remember the answer. So, did you guys do proofs in geometry? I would hope so, you better have. Okay, basically 10.1 is proofs, okay? So that's the gist of what we're gonna do in section 10.1. First, here's how proofs tend to go. Like a lot of times students are like, they get everything they're taught. Like it makes sense. Ms. Roberts, you're doing the proof. Yep, I understand how you went from there to there, and I understand how you went from there to there. Got it, got it, got it, got it. And then you get on your own and you're like, I don't know what to do. That's usually how proofs tend to go, okay? So this is gonna be a section, yes, listening to Ms. Roberts, that's gonna be important. But practicing these proofs, that's gonna be really, really important to be able to do them on your own with your own knowledge. So just be aware, some students tend to get caught on this section. All right, so a couple things. I love the fact that I give all this stuff, you know, like how much of this have you already done in the last few years? Have you been substituting the last few years? Yeah. How about multiplying and dividing or adding and subtracting or working with the order of operations? You've done all of that. So really what we're doing today isn't new. It's just that I'm applying all these old rules that we've been working with forever to trigonometry. Okay, so I'm going to be substituting. I'm going to be adding and subtracting, multiplying and dividing, making sure I follow the order of operations, etc. The identities, these first ones you're totally familiar with. You've seen those before. So can you grab the front lights? Thank you. So those are no big deal. However, the second set, the Pythagorean identities, these are new identities. You haven't seen these before. This is right here in the video, this is a really big concept. Make sure that your power is located in the right spot, because locating it in the wrong spot will cause it to be wrong math. Okay, it's not just that, oh, I'm sorry, I put it in the wrong place. I knew what I was doing. It totally, as I'm reading it, it totally makes it a different mathematical statement. So, so make sure that your power goes in the correct place. So then I think that finishing up the Pythagorean identities, I'm guessing was the embedded question. Okay, so then if you rearrange to find cosine squared, what do you get? 1 minus sine squared. By the way, did you hear that I'm a little lazy in my speech? I say sine squared, but I don't actually say sine squared theta. Okay, so I don't care if you're lazy in your speech, but you're never allowed to be lazy in your handwriting. Okay, even if I didn't say theta, I still wrote theta. Just remember that when it comes to trig, you're not allowed to have a sine or any other trig function that doesn't have an angle with it. They belong together. So you can't just have a freestanding sine that belongs to nobody, or it has to be the sine of a theta. So yeah, I'm being lazy in my speech, and I'm fine if you are as well, but you cannot be lazy in your handwriting. And if you are, I just take off points. Okay, so just be aware of that. Okay, so the second trig Pythagorean identity, how can we rearrange to get tangent squared alone? Yeah, secant squared theta minus 1. And then what if I wanted to just isolate the 1? Yeah, so no big deal on those. And then the last one, same concept, cotangent squared will be equal to, and then if the 1 is alone, okay, so hang on, I can't spell cosecant. So just a side note, a way that, the first one I never have a hard time remembering, sine squared plus cosine squared equals 1. I never have a hard time remembering that one. And essentially that comes from a squared plus b squared equals c squared. Think about it with me. What is the y value on the unit circle always attached to? What is the y value always attached to? The sine value. What's the x value always attached to? The cosine value. So think about it. The x value squared plus the y value squared on the unit circle now is equal to the hypotenuse squared. Remember our reference triangle that we kept going back to? And in our unit circle, the hypotenuse is always 1. Okay, so it's an x squared plus a y squared is equal to my hypotenuse squared, my 1 squared. Well, that's really what we're talking about here. My x squared is the cosine. My y squared is the sine squared. And that is equal to 1. So really, number 1 is just the Pythagorean theorem. That's all that one is. Maybe that's why we call them the Pythagorean identities. Because they're all based on the Pythagorean theorem. Okay, so that's why we call them Pythagorean identities. The second two, though, I tend to have a hard time remembering what's what. And so I came up with some really stupid sentences. We all know that the stupider something is that even a word? Stupider? The stupider something is, the more we remember it, right? Okay, so this takes the cake. Okay, these are pretty stupid. You're going to find out. So the first one, this guy, I said, okay, here's a sentence that will help me to remember this. And if you could ever come up with a better sentence, you just let me know. I would love to have something that doesn't sound quite so stupid. Okay. So here's what I have. 1. Okay, so there's my 1. Truck. So T, truck, is, there's my equals. My S, sensational. 1, I told you it was stupid. Don't worry, the next one's even worse. All right, so 1 truck is sensational. That just helps me to remember. A dumb statement like that helps me to remember what my Pythagorean identity is. The second one, the one that's worse. I couldn't just choose any C words, right? Because they're both C words. So I didn't have my pick of the dictionary on here, okay? And by the way, there's not too many words that have CSC in them. The list is very short. Okay, so here we go. Ready? Stupid statement number 2. Again, 1 cot. Okay, so that one makes sense. You know what a cot is. Something you sleep on in the army. Okay. 1 cot is cascading down the mountain. No, did you just get a dumb picture in your head? Yes, you did. Okay, so this is going to help you to remember it a little bit better. So 1 cot is cascading down the mountain, and all of a sudden, it's going to be very difficult to forget those. Okay, so anyway. All right, so what we're going to do is we're going to use all of that stuff that we've been using for years and years and years. We're going to use substitution and adding and subtracting, and multiplying, dividing, etc., to rewrite some trigonometric statements. Now, notice I said that this is a statement. It's not no, I'm not even gonna go there. It's not important. All right, so we're just gonna change our trigonometric statement here. Now, we've got some things that we're allowed to use. We're allowed to use quotient identities, and we're allowed to use Pythagorean identities, and then we're allowed to use our, elementary stuff: substitution, add, subtract, multiply, divide. Okay. So, so one thing here that I'm going to recommend many times, not 100% of the time, but many times, if you can get everything in terms of sines and cosines, it makes your life easier. Okay, so if we can turn everything into sines and cosines, it makes things a little bit simpler. So let's take a look at example 1. Now my iPad thinks that I'm misspelling these words. I'm not. Okay, they're not underlined for any special reason. So what is something that we know to be true about cotangents that I'm allowed to substitute? What does cotangent equal? Sine over cosine? Cosine over sine? There's one more. 1 over tangent. Okay, but since I just said let's turn them into sines and cosines, We'll stick with the cosine over sine. By the way, which one is sine over cosine? That one's tangent. Okay, so let's take cotangent out and let's replace it with cosine over sine. And once again, you hear that my speech is being lazy, but my handwriting is not. I'm not leaving the angles out. I'm still writing them. I might leave them out in my words, but I'm not leaving them out in my handwriting. All right, now sine squared, now I'm multiplying these. Sine squared is already in terms of sine or cosine. So I say, let's just turn it into a fraction since my first guy was a fraction. How would you write sine squared as a fraction? Over 1. Yeah, sine squared over 1. Okay, how about cosecant? What can I substitute for cosecant? 1 over sine. Now, what kind of math can I do with this? Yeah, multiply. How do you multiply fractions? Yeah, multiply the tops, multiply the bottoms. But wait. Isn't there something else I can do before I multiply? Yeah, let's start canceling some junk that I don't need. All right, so what can be canceled? Okay, well, when you cancel ones, you're left over with ones. So there's that. So I'm not going to cancel the ones because they get replaced by ones. What else can I cancel? Yeah, how many signs do I have on top? 2 on top. How many on bottom? 2. So let's cancel the 2 on top with the 2 on bottom. Okay, now let's look at what's left over. On top, I've got a cosine times a 1, which is cosine. And on bottom, what's left over? 1. What is cosine over 1? Oh, okay. Now, which statement is simpler, the original statement or the final statement? Yeah, the final one. Not only that, it told me to rewrite it as a single trigonometric function. So I was able to reduce everything down to just a single trig function. Okay. All right. You try number 2. Again, step number 1, let's get everything into sines and cosines. And then step number 2, let's do the math. Add, subtract, multiply, divide, etc. All right, you ready? Okay, let's see here. Cecilia, what are you gonna substitute for the first piece for cosecant? Very good. All right, and don't forget, guys, that this is a theta, so this is 1 over sine theta. Okay. All right, Natalie, what are you gonna substitute for the second piece? 1 over cosine. All over. Priscilla, what are you going to substitute for the third piece? Cosine over sine. Okay, so that's pure substitution. There really isn't a whole lot of math that we've done yet, just pure substitution. Okay, so now I'm ready for some math. What are the operations that I've been given to do? Multiplication and division, okay? And so how do you divide fractions? Yeah, keep, change, flip, keep, drop, flip, drop, change, flip, I mean, that's what I meant to say. Multiply by the reciprocal, invert and multiply. All of these are different ways to say the same thing. So what I'm gonna do is I'm gonna just not even touch the top for right now. All I'm gonna do is take the bottom and flip it over and write it as multiplying. So this is gonna be 1 over sine times 1 over cosine. Those are unchanged, I didn't do anything with those. And now multiplying by the bottom guy and inverting. So this is gonna be sine theta over cosine theta. All right, what can I do? I can cancel out a sign on top and a sign on bottom. What's left on top? 1. What's left on bottom? Cosine squared. Now you're not finished with that because there is a way that I can write 1 over cosine squared that's simpler. So what is 1 over cosine squared the same thing as? Secant squared. Yeah, secant squared. I mean, think about it. 1 over cosine squared means 1 over cosine times 1 over cosine. Okay, so that's going to be secant times secant, which is secant squared. Okay. Let me make a note here before I move on. Let me turn this so I can show you these two. Did you notice how for both of these? Thank you. Did you notice how for both of these I did not work from left to right, I worked from top to bottom? So if you're already doing that, keep on doing that. But if you're one who you like to work from side to side, change your habits. It might not be such a big deal on these first few questions, but when I get later in the section where I'm verifying the identity, don't work from left to right, it will mess you up. And remember, I'm the one that has to grade, and if you're messing me up, I just count it wrong. Okay, so part of what you're learning today is not just some proof. Part of what you're learning is how to be organized in your math. Now, the second thing I want to point out, how many equal signs have you seen me write so far today? Not one. You shouldn't have any either. Now, if you work from side to side, you have to use equal signs. But if you work from top to bottom, you do not have to use equal signs, okay? And in a few minutes, I'm gonna find that the equal sign is actually a different meaning today, okay? So don't use the equal sign, that's gonna mess you up, it'll mess me up, the grader, okay? So work down, work from top to bottom, get yourself into that habit. It will help you to be more organized in your math, and this will carry over to other classes. This isn't just about Math 111. Okay, for those of you who plan to take Math 140 next semester, this is going to carry over into that class. If you plan to take other math classes, once you get into your 4-year degree, it will carry over into those. So just understand, good mathematicians work from top to bottom, and they're very organized in their work so that somebody else can come along and can look at anything that you've written and totally understand what your brain was doing. Okay, this is a way that I get to read your mind. All right, okay, so example number 3. By the way, what's over on the right was just an example of, hey, we really did do this. This is something we would have done in like a pre-algebra class in junior high, and we would have simplified this. So I'm just kind of showing you that in pre-algebra we did the same math, but now we're doing this with trigonometric functions. Oh, look, we got a new Greek letter. This is alpha. So do you remember how I said a few minutes ago that most of the time life is easier if you change everything to sines and cosines? This is one of those times where you can do that. You can change into sines and cosines, okay? But it's actually easier if you don't. This is one of those times where it's easier if you don't, okay? So we have some other identities that we can use that don't involve sines and cosines. So what is 1 over tangent squared the same thing as? Cotangent squared. And what do you know about tangents and cotangents? They're reciprocals of each other. They're reciprocals of each other, okay? So what I would do here is I would either change the cotangent into 1 over tangent, or I would change the tangent into 1 over cotangent. Either one, it doesn't matter, because what's going to happen when we multiply those two together? What will we get? Okay, let's find out. Okay, so let's take cotangent and turn it into 1 over tangent. Yeah, you get 1. By the way, this is a time where I'm using the order of operations. What are all of the operations up there in that statement? Yeah, adding and multiplying. And what has to come first according to the order of ops? Multiplying has to come first. So these are going to cancel. And when they cancel, what am I left with? I'm left with a 1. Hey, what does cotangent squared plus 1 equal? No. 1 cot is cascading down the mountain. This is cosecant squared. Now again, you could have worked this problem by changing everything into sines and cosines. It just would have taken longer. Okay, there would be more work involved in it. Okay, so not every time is sines and cosines going to be the easier route. It's always an option, just not always the easiest option. Okay, more of the same. You guys do number 4. Jaden, what'd you get for the first one? Okay. Selena, what'd you get for the second one? Okay, that is definitely true, Selena, but in this one, take a look at the directions. Yeah, so you're right, but because the directions specifically say sines and cosines, we'll go ahead and do it that way. What about the third one? Yeah, it's already, or sine over 1, either one. What happens? Yeah, sines and cosines both cancel out. Yeah, you can say the 1 cancels out, but no, yeah. And what's left? 1. Well, that was a lot of work for just a 1. The next question, guys, I want you to see it while I'm looking at the directions. The next question, I would never ask you this question with this set of directions. I would never ask you number 5 with this set of directions. Number 5, I would only say simplify. Okay, because I would be making it harder on you to follow these directions. Okay, and that's not what I'm all about. All right, so let's change the directions. I get to do that. I'm the teacher. Okay, you're not allowed to do that, but I get to do that. So I'm just going to say simplify. So what would be a good way to simplify this? By the way, I could change everything into sines and cosines. That would be legal. Yeah, let's go cascading down the mountain. So we've got 1 over cosecant squared. And then what is 1 over cosecant squared? Yeah, sine squared. Okay, now just for kicks, let me show you what it would have looked like if I had worked with sines and cosines. Okay, so you don't have to write this down, but just take a look at what it would have looked like. So we would have had a 1 over 1 plus cosine squared theta over sine squared theta. Now, I am not dividing fractions right now. Notice I'm dividing by a 1 plus a fraction. I'm not dividing by a fraction. So I have to simplify the denominator first before I can use multiply by the reciprocal. So I would have to get a common denominator. Okay, so I would keep my 1 on top. The bottom, I would make my common denominator sine squared. This guy is still the cosine squared. I haven't changed that guy. What does 1 turn into if you've got a sine squared on bottom? Yeah, sine squared over sine squared. Okay, so now take a look. What is sine squared plus cosine squared? Uh-oh. Yeah, it's one of your identities. It's 1. It's the first Pythagorean identity. So this is 1 over sine squared. You with me? Hey, what's 1 over sine squared? Cosecant squared. So this is 1 over cosecant squared. Hey, what's 1 over cosecant squared? So, okay, so can you see how much more effort that one took? Okay, so that's why I say I would never ask you number 5 and tell you that you are required to use sines and cosines. I would never do that. All right, it can be done. It's just way more work. Okay, number 6. What's the rule for adding and subtracting fractions? Yeah, you got to have a common denominator. Get a common denominator. Okay, so what do you think is the, okay, I got 2 options. I could get a common denominator right this minute. What would my common denominator be? Think about if you had 3/4 plus 4/3. What's the common denominator? 12, right? Because you took your 2 denominators. They don't have anything in common. So the least common multiple we would say is 12. Okay, so with that said then, let's come back over here. What would my common denominator be? Cosecant times secant. Cosecant times secant. Okay, so that's totally an option. Option number 2 would be what? Turn things into sines and cosines. You say, well, Ms. Roberts, which one's the easier? Yeah, I don't know. I don't remember. I've worked them both ways, but I don't remember. Okay, so what would you like to choose to do? Would you rather get sines and cosines, or would you rather get a common denominator from the start? Common denominator? All right. And I would have said okay to whichever one you chose because I don't really care. So my common denominator is cosecant times secant. Okay, now just to remind you guys how to add and subtract fractions and get a common denominator, what is it that you have to multiply this fraction by so that your old denominator matches your new denominator? What do you have to multiply this fraction by so that the old denominator matches the new denominator? I'm not going to multiply by the new denominator, no. Secant over secant. Why is that legal to multiply by secant over secant? Yeah, it's just the number 1. And what does that make my new numerator? Secant squared. Okay, let's do the same thing for the second fraction. What do you need to multiply the second fraction by so that the old denominator matches the new denominator? Cosecant over cosecant. And the new numerator? Cosecant squared. Okay. Question, can I cancel a pair of secants and a pair of cosecants? No, why not? Because it's addition. You can only cancel in multiplying. Okay, so that's not an option. So now what? Do you know what secant squared plus cosecant squared is? Say no, because I don't. Okay, what should I do? Yeah, now let's turn into sines and cosines because we don't know what to do. Okay, so we had to go back to that anyway. All right, so what does the first guy become? One over cosine squared plus the second guy. One over sine squared. All over. What's that? Yes, but if we're turning everything into sines and cosines, I say we do the whole thing. So what's the first guy going to become? 1 over sine. And the second guy? 1 over cosine. And is it okay to write it like that? Is that legal? Yeah, that's legal. Okay, so again, my brain goes in at least two directions. That's one thing that can happen here. You might take a different direction than your classmate might. You might take a different direction than I take, but it's still correct, okay? So there's multiple options. My brain goes in two directions right now that we could do. What would be your suggestion? Just think old math. Okay, so let's get the reciprocal. Multiply by the reciprocal. So we've got 1 over cosine squared plus 1 over sine squared. And that's going to all be multiplied by sine of x cosine of x. Over 1. Do we really need that over 1? You can put it if you want it. It's fine. But it's not necessary. How am I going to multiply that? Ah, yes, I have to distribute. Okay. So I'll have sine cosine over cosine squared plus sine cosine over sine squared. Now what? What can I cancel? Anything in the first term? A pair of cosines, right? What will that leave you with? What about in the second term? What will that leave you with? Is this as simple as you can get it? No? What's sine over cosine? What is cosine over sine? Is that as simple as you can get it? Do I have any identities that go with those? I would say that's as simple as it's going to get. But I'd like to show you how what I meant by two people can take two different routes and they're the same thing. Okay, so let me show you one more route. Can you come to where this second, where we ended with this second line? Okay, and feel free to write this down or not write this down. I don't care. You can just watch if you want. What if here, instead of changing into tangents and cotangents, What if I had gotten a common denominator again? Okay, now I'm gonna skip a step. Normally, I don't skip steps, but since I'm just showing something for the fun of it, I'm gonna skip a step. If I were to get a common denominator, I would end up with sine squared plus cosine squared over sine cosine. All right, do you agree that my common denominator would be sine times cosine? Right, and what is on top, sine squared plus cosine squared? Pythagorean identity. It's 1. And what is 1 over sine? No. 1 over sine? Cosecant. What's 1 over cosine? Secant. Now take a look. It's weird to think that this answer here is the same as this answer. You really cannot see the equivalence, but they are. So see, two people could take the same question and go different routes and still end up correct. Because quite frankly, I can't tell you which one looks more simple. Does this one look more simple or does this one look more simple? I don't have an answer for that. Okay, so I will tell you, this is probably my favorite section to teach and to work, and it's my least favorite to grade. Because I can't have a key, because two students can take two different routes and still be correct. Okay, this is why I keep saying it's so important for you to be organized, because if I can't tell what you're doing, if I can't tell what your brain is doing, I just mark it wrong. Okay, so your brain might have been thinking correctly, but you didn't put it down on paper well enough for me to understand it. All right, take a look at number 7. So again, my brain goes in a couple of different directions. So you tell me, what's something that you would think of doing? By the way, this is a new Greek letter, beta. This is beta, okay? What could you do? What's one thing that you could do? You could distribute the cosine. What's another thing you could do? Sines and cosines on the inside, okay? So, and both of those are correct, and I gotta tell you, I'm not certain that one's easier than the other. All right, so what would you like to do then? What was that? Distribute? Okay. So we've got then the cosine of beta times the secant of beta plus the cosine of beta times the cosecant of beta. What do you know about cosines and secants? Don't use that word. Yeah, they're reciprocals of each other. The reason I say that, Aaliyah, is that could get confusing since inverses find angles, and we're not trying to do that right now. So, so they're reciprocals of each other. So this is going to be cosine of beta times 1 over cosine of beta. So those two are going to cancel, leaving me with a 1. Plus, all right, so now let's go ahead and turn into sines and cosines. Cosine of beta times 1 over sine of beta. Okay, so this is cosine over sine. What is cosine over sine? Cotangent. 1 plus cotangent beta. What's that equal to? Is it equal to cosecant? No, why not? Yeah, so guys, here's a big lesson for today. You can only use Pythagorean identities if you have squares. You can only use Pythagorean identities if you have squares. Okay, big deal, big deal. All right, here we go. Here's really the climax of this section. This is why we've done everything that we've done today. Verify the identity. Verify the identity. Okay, so those 3 words basically means prove that the right side is truly equal to the left side. Okay, remember how a few minutes ago I said today the equal sign isn't going to mean what it normally means. Because normally an equal sign is something where we're supposed to solve for something. I'm not trying to solve for anything. That equal sign today, and if you don't get anything else I say today, this is probably the one thing you got to hang on to. That equal sign is a brick wall. You may not cross over it. Like normally you can cross over an equal sign, right? Like you can add the same thing on both sides or multiply this so that you can start rearranging and get what's on the right going. You can normally do that, yeah? Not today. That equal sign is a brick wall. Whatever's on the left stays on the left. Whatever's on the right stays on the right. And never the twain shall meet. And your goal is to do what we've been doing. Manipulate the left side. Manipulate the right side. Your goal is to get them identical at the end. Your goal is to show me that the left side and the right side are truly the same thing. Okay? So, and notice that I use the word show. You got to show me this. I'm never going to lie to you about that equal sign. So you can't just look at number 8 and say, well, Ms. Roberts, there's an equal sign there, so of course they're equal. Right. Yes, that's a true statement. But you must show me that the left truly equals the right. Okay? And I got to be able to understand what you're showing me. So that's where the proving comes in. Okay, so let's do what we've been doing. Look at some tips that I've given you. Tip number 1, figure out what looks more complicated and work with that side. Try to change it into the simple side. 2, focus on your ultimate goal. In other words, don't forget where you're going. Like, have you ever walked into a room and you go, I have no idea why I came in here. There was a reason I came in here, but I don't remember what it was. Don't forget where you're going. If you don't know where you're going, you're probably not going to get there. Okay? So to keep your eyes on the goal. Don't forget where you're going. Number 3, changing the signs and cosines. We just said that. Number 4, work both sides separately. So what happens, sometimes a question will look just as complicated on the left as it does on the right. So what you could do is work on the left until you get stuck. Okay, I quit. Work on the right until you get stuck. And what you're hoping for is that you get stuck in the same place. That's what you're hoping for, okay? And then number 5, you might have to use some conjugates, and I will show you that. Like conjugates from Math 110 kind of conjugates, okay? All right, so let's take a look at number 8. Which side looks more complicated? Definitely the left side. So let's see what we can do to manipulate the left side and turn it into the right side, okay? So how could we manipulate the left side doing what we've been doing all class period? Yeah, so tangent is the same thing as, okay, sine over cosine. Over, secant is the same thing as 1 over cosine. Now, do you notice how I'm working down? Okay, I'm still not going to work. This right here is why you especially cannot work left to right. Okay, and now what can I do mathematically? So we got sine theta over cosine theta times the reciprocal cosine theta over 1. What can I do? Yay, and I'm left with sine. And hey, take a look. That's what I was trying to turn it into. So I took the left side, I manipulated it until it became the right side. All right, look at number 9. What would you choose to do for number 9? Say it again. Okay, so you could distribute. Savannah, what did you say? Because there is more than one right answer. Chicken. What else could I do? I hear you muttering. I just don't know what you're saying. Sines and cosines. Okay, that's option number 2. I'm looking for a specific option. that I haven't heard yet? Pythagorean, which one, Selena? She says Pythagorean identity, which one? Which one should we use? One cascading down the mountainside? Okay. I personally think that's the easiest option. But just because I think that's the easiest one doesn't mean that you have to go that route. You can still distribute. You can still change into sines and cosines. That's fine. I'm going to go my way, though, because it's easier. So we got sine squared beta. What you just told me, what is 1 plus cotangent squared the same thing as? Cosecant squared. Hey, what do you know about sines and cosecants? They're reciprocals of each other. So this is going to be sine squared beta times 1 over sine squared beta. And what just happened? Yeah, and by the way, you're not done. You do have to actually show me that it's equal to 1. So don't quit in the middle. Okay, on this one, if we were in a normal math class, and if I hadn't told you today that that equal sign is a brick wall, what would be one thing that you would like to do to this? Cross multiply. But see, that would be switching sides. So that's not an option for today. Now, don't worry. When we get into the last section of chapter 10, that'll be an option because I'll actually be solving. So that's still legal, but it's not legal for verify the identity. Okay? You cannot cause the left side to go to the right or vice versa. So even though cross multiplying is something that's legal, you can't do that today. All right. Secondly, look at the numerator on the left side. Look at the denominator on the right side. Now, if you were looking at that, is there something that you wish they had? Squares? Yeah, Marina, why would it be nice to have some squares there? Pythagorean identities, yeah, that's the word. You can change them into the Pythagorean identities. Okay, so if you ever get to a point where you're looking at something again and you say, man, that's so close to my Pythagorean identities, but I'm missing out on a square or some squares. If you ever say that to yourself, use conjugates. Because if you use conjugates, you'll be able to get those squares that you want. Okay, now I'm not going to go with conjugates on both sides until I know that I have to. So we're just going to pick a side and do conjugates on one side. And this is another time where you say, which one's more complicated looking, the left or the right? Toss a coin, right? I mean, one looks just about as complicated as the other. So I'm going to start with the left side because it's on the left. That's the best reason I got for you. Okay, and since I really, really wish I could have some squares, I'm going to use conjugates. So take a look at the numerator. What's the conjugate of the numerator? I know I'm making you remember something from Math 110. What's the conjugate of the numerator? Yeah, cosine minus 1. So you remember conjugates are where you take the first piece, leave it alone. The second piece, you change it from you negate it. Pos to neg, neg to pos, okay? And then we multiply by conjugates. So I'm going to multiply by the conjugate on top and on bottom. Cosine theta minus 1 over cosine theta minus 1. Now I want you to tell me, why is that legal? It's just equal to the value of 1. Okay, so it's legal for me to do that. Now on top, let's FOIL, and it's a difference of 2 perfect squares. Okay, that's why conjugates make things so nice. So when I FOIL on top, what do I have? Do you mean cosine squared? Yeah, -1. Because the outers and the inners, they zero each other out. Outers and the inners zero each other out. Okay, now on the bottom, for the time being, I'm just going to leave it, I'm not going to multiply. Actually, I'm not going to multiply, but could I change the tangent into something? Sine over cosine? Actually, sine squared over cosine squared? Now you have to be careful in this next question. What does the numerator equal? Because remember, the whole point of using conjugates is so that I could get some squares, so that I could use my Pythagorean identities. But you got to be careful on this one. What does cosine squared -1 equal? Negative sine squared. Why is it a negative sine squared? Is it listed on that page from the video? It's not. It's not. You have to, but it's one of those where you just have to rearrange it on your own. Okay, so that top then is a negative sine squared. Okay, now what do we do with the bottom? Is it starting to look like the other side? Remember, one of your tips was make sure you keep focused on where you're going. Is it starting to look like the other side? I don't think it is. Not yet. Not yet, but that's okay. We'll keep on going, okay? So we'll go until we're stuck. And then when we're stuck, we'll go to the other side and do the same thing, okay? So what's something I could do down in the denominator? Good question. Can you cancel out a cosine? No, why not? You've got some subtraction in there. Yeah, that cosine -1, that prevents you from canceling a pair of cosines. Good thought, not an option. Okay, what else could I do? Reciprocal? Yeah, I can do that. I can do that. All right, so you just have to be really careful when you do this, because reciprocal only works when you're dividing by a fraction, and right now I'm not dividing by a fraction. Right now I'm dividing by a product. Okay, so you have to be careful about this. All right, so here's what I'm going to do. I'm going to multiply the tops. All right, so this is going to be cosine theta -1 times sine squared. So there's multiplying the tops. Divided by the bottom, cosine squared. Now that I'm dividing by a fraction, now it's legal for me to multiply by the reciprocal. Okay, are you with me? Don't, I know we're getting to that time in the class period where you start going, no. Okay, so stick with me. So now let's invert and multiply. Negative sine squared times cosine squared over cosine theta -1 times sine squared theta. Okay, can I do anything with that? Cancel what? What's that? Uh-huh, A sine squared over a sine squared with a negative? Yep, absolutely. So the sine squareds will cancel. The negative stays there. And the cool thing is you can put the negative on top or you can put the negative on bottom. Doesn't really matter. So for now, I'll leave it on top, but I might change my mind and put it on bottom later. Okay. Is it starting to get a little closer? It's getting closer. Still not where we want it to be, but it is getting closer. Okay. But I would probably say at this point that I'm officially stuck. Okay, so what do you do when you get stuck? You don't quit. You go to the other side. Now what I'm going to do is I'm going to draw a bar here that represents my equal sign, showing that everything on the left is on the left and everything on the right is on the right. What are you thinking, Aaliyah? What's that? This side or the original? This guy? What were you thinking? You could. No, you could just distribute the negative on the bottom. So, okay. Oh, I gotcha. 1 minus cosine is not the same thing as sine. Gotcha. Gotcha. All right, so now let's go to the other side. So what can I do on the other side? Let me say this. You remember how I told you that sometimes we look at something and go, man, I wish I had squares there so I could use the Pythagorean identity? If I had squares, what Pythagorean identity would I end up using? If I had squares, what Pythagorean identity would I end up using here? Yeah, the one that has a tangent in it. Now, again, remember how you want to focus on where you're going? Do you really want to introduce some tangents into this? I'm thinking no. Okay, so yeah, it might be nice to use those, but I don't really think it would be very helpful. I think it would take us a long way around. So instead of Pythagorean identities, what might be a good idea? Sines and cosines, absolutely. All right, so let's leave the top alone. What will the bottom look like? One over cosine minus 1. But can we go ahead and get a common denominator with that instead of writing the number 1? What would be, what would I write if I were getting a common denominator? Cosine over cosine. Now remember, you cannot use multiply by the reciprocal until you're dividing by a fraction. Okay, so right now I'm dividing by a subtraction problem. So let's write a single fraction on bottom. What does the single fraction look like? No, not cosine squared. It's already a common denominator. It's just cosine. It's all, remember when you're adding and subtracting fractions, you get that common denominator and you keep the common denominator. Okay. Can we invert and multiply? So that's going to be cosine theta times cosine theta over 1 minus cosine theta. Oh, are you starting to see that this is going to emerge soon here? Pretty close. What do I have on top? Cosine squared over 1 minus cosine. Okay, they're not identical. They're not identical, but it's within reach. What's the only thing I need to do to change it? Yeah, move that negative to the bottom. This guy over here, let's take that negative and move it down to the bottom. Okay, so when you move the negative to the bottom, that'll be a cosine squared on top, and it'll be a 1 minus cosine on bottom. Oh, they're the same. That took a little while, didn't it? And that's not the only route to take. All right. Do you want to try one? No? All right, we'll do one more. You can try number 12. Okay, we'll do one more together. Which side looks more complicated? Eeny, meeny, miny, moe. Which side do you want to start working on? The left? Okay, what do you want to do? Turn it into sines and cosines? Oh. Okay, any other ideas? The right side? Okay. What do you want to do with it? Sines and cosines? That's a good idea. So what do you get for the first one? Okay. What kind of math do you do to be able to subtract those? How do you add and subtract fractions? Get a common denominator. So what do you want your common denominator to be? Yeah, like the one that's already there. Now the first fraction, it's good, right? It already has that denominator. It already matches. So let's just write down the numerator. The second one though doesn't have it. So what do you need to do to the second fraction? Multiply by cosine over cosine. So what's your new numerator? Cosine squared. Now keep an eye on the prize. Keep an eye on what you want to change it to. Are you close? What is 1 minus cosine squared? Sine squared. Yeah. So let's take the numerator and substitute sine squared. Hey, what just happened? See, that one wasn't too bad. You should have taken that one. Okay. Yours is number 12. You can work together. You can work together. Savannah and Bethany, you guys will have to include, well, either that or Cecilia, you can work with Selena. Dylan, insert yourself into a group since you don't have your partner. catch.
I'm just looking at okay, I understand how you look at that. That makes sense. Okay. Now, how did you get okay, and is this the tangent of S? This S looks like a power. It's not a power, right? Okay. So then this is really confusing. You don't want to tangent square, do you?
So I thought that one over like that, yeah, like that was square over sine.
Okay. So
Think about this, right? I agree with the let me see we can fix it all. You just smash those your cosine squared, your sine squared, all of those cosine.
what you need to do to this fraction to make the
From there, the numerator has
what's missing. So then all you're gonna do is just take this fraction and multiply by this. And then do the same thing. So yeah, up here then you won't have that sign. You won't have that. Yes, sir. So I would definitely show multiplying cosine for cosine. And then on this one, what we see.
So it's one all over cosine. And from there, we can do this.
All right, so let's take a look. I actually saw a couple of different methods that was being used. So I love that. I love that you guys, some of you are using sines and cosines. Some of you stuck with tangents and cotangents, and I'm good with either of those. Now I'm only gonna work it one way, all right, just for sake of time. So most of you turned into sines and cosines. So if that's the case, this is gonna be cosine of S over sine of S, S plus sine over cosine. Getting a common denominator then, your common denominator will be sine cosine. This guy is missing the cosine. I don't know why it's hard to write an angle of S for some reason. I don't know. And then this guy is missing the sine. I don't know, it just feels sinful or something. So thanks, I'm glad somebody got it. All right, so on top we've got cosine squared plus sine squared. We know that cosine squared plus sine squared is equal to 1. Some of you stopped there. Some of you took that one step further to say that 1 over sine is cosecant and 1 over cosine is secant. And then you said, oh, look, hey, that's the same thing. Some of you went to the other side and you turned the secants and the cosecants into sines and cosines, and that's fine too. Let me make one statement. Okay, are my two final lines, the original over there that's typed in and what I last wrote, are they identical, identical, identical? They're not. What's the only thing lacking? How are they not identical? The commutative property, right? They're just not traded. But I'm fine with you. I consider if the only thing left to do is the commutative property, I consider that identical enough. Okay? That can be the only thing that I let slide through. Okay? So if it's just a commutative property thing, then I'm all right with letting that slide through. Okay, let's see what we can do here for number 13. I know that we have a couple questions left here with only 5 minutes. So let's talk about number 13. Number 13 totally brings up Math 102 and Math 110 concepts, specifically factoring. Okay, a lot of people think, oh, this is Math 111, I never have to factor, woohoo. Yeah, no, false. Okay, so this is factoring. So let's take a look at the left side. All right, how could I factor the left side? And what you would have done in Math 102 and Math 110, you would have factored things like a to the fourth minus b to the fourth. So how does that factor? How does a to the fourth minus b to the fourth factor? Nope. Hint? Difference of squares? Okay. How would you have factored a squared minus b squared? A minus b times, it's not a minus b, a plus b. A minus b times a plus b. Okay. All right, that's a difference of squares. So is this. How would you have factored this in Math 102 and Math 110? Say it louder. Do you have a voice? Or did you lose it? Oh, okay. We'll use that voice. It doesn't matter if it's right or wrong. I don't care if you make a mistake. Yes, there's more. Somebody finish it for her. A squared minus b squared. Oh, yeah. Oh, yeah. Math 102 stuff. Who needs to remember that? So let's go over to number 13 and let's use that concept. So actually, I'm not going to use that concept. This is where I'm going to stop for today. So let me say this. I didn't get as far as I wanted, so here's what I'm going to do. What did you tell me that the practice test due date was? 18. Oh, okay. So let's do this. I'm going to take this class day and this class day, and I'm going to trade them. Okay, now the test is still going to stop at 10.1. The test will still stop at 10.1. Okay, but I'm going to trade those 2 days for 2 reasons. Number one, it'll give me a chance to finish 10.1, and it'll give you a longer chance to practice 10.1. Okay, so for those 2 reasons. Now, I don't get out of class today until 3:30. So by the time I get out of class, I'm going to totally forget that I need to change dates in my lab. I need somebody to text me and remind me, because I'm going to forget otherwise. Okay, because by 3:30, I'm like, I get back to my office and I'm like, okay. So, because literally I'm teaching straight from 11 to 3:30. So I'll be so tired that I'll forget. So I need somebody to remind me to change the dates in my lab for that. Okay. All right. That's all I'm going to do for today. I will see you on Monday. Have a good weekend. All right. So I believe that we left off, we started talking about 13, but we didn't get anywhere with it. Am I remembering correctly? Okay. So let's just jump right on in. We'll finish up with 10.1. I will take any questions that you have at that point. And then we'll go into 10.2. Okay, so that's the plan for today, and we'll get as much done as we can in 10.2, if not even the whole entire section, which would be phenomenal. Okay, so let's go back to number 13 and let's remember where we left off. We were looking at the left side, okay, and the left side is just a difference of two perfect squares. And so it's basically like a Math 101, Math 102 concept where we want to factor. All right, so when we met last, we talked about the fact that a to the fourth minus b to the fourth is the same thing as a squared plus b squared, a squared minus b squared. Okay, actually this can factor a little further, can't it? What else can be factored in this second line here? Again, Math 101, Math 102, pre-algebra stuff, Algebra 1. Can you say it again? Yeah, so how can it be factored again then? Which piece are you looking at, Savannah? The first factor or the second factor? The first? How would you factor the first one? I didn't understand the first part. What'd you say? A plus b squared. Is this, okay, so this is a good question then. Is this the same thing as a plus b, the quantity squared? We have some varied opinions. Those of you who are saying no, why do you say no? Can you say it again? Uh-huh. Yeah. Yeah, so how do I do the one in red? I would have to FOIL, which would cause a middle term, right? There would be a 2AB in the middle if I were to FOIL that red guy out. So the purple guy and the red guy, they're not the same. Okay, they're not the same. All right, so I can still factor further though. So how can I factor further? Yeah, absolutely. Priscilla, was that you? I couldn't tell. Yeah, absolutely. It's another difference of two perfect squares. Okay, so that second factor can be factored to a plus b, a minus b. All right, so now let's take our algebra skills and let's go over here to our trigonometry and apply the algebra skills to the trigonometry. Okay, so how can I factor the left side? Oh my goodness, this is going to be a really boring class period. I can feel it in my bones. All right, so I'm just going to start calling. Bethany, how do I factor the left side? Oops. You are correct. Okay. Let me build my brick wall here for my equal sign that I'm not allowed to pass over. Okay, can I factor either of those again? The right one? Okay, how can the right one be factored? One. Okay. What about the first factor? Mayona, what do I know about the first factor? It's a Pythagorean identity. So what's it equal to? Yep. Now, one of the tips that I gave you is that you should always keep in mind what your goal is. Have I made the two sides be alike yet? Are they alike? They're not. They're not. In fact, that extra bit of factoring, even though that's the route I led you, isn't really useful. That extra bit of factoring is not useful. Okay, take a look. I want you to compare the two sides. So we're looking at this side right here, and I want you to compare it to this side. Now remember, this side is exactly the same as this guy times 1. Okay, so when you are comparing those two sides, do you notice how the unfactored version at least has a sine squared in it, but this guy does not? But look over here, I want a sine squared. It would be nice if I had a sine squared, right? So this is one of those times where, what I did was totally correct, but it wasn't useful. It wasn't useful, and that's okay to make a mistake like that. Okay, so let's rewrite that second line as a 1 times. Let's go back to where it was before, sine squared minus cosine squared. Because at least that way I had a sine squared in there. At least I had one little piece that was similar to the other side. Okay, and by the way, proving sometimes is trial and error. Try a little bit. Oh dear, I made a mistake. Let me back up. That's okay. That's all right. That's completely normal. Okay, so I'm still trying to make it like the other side. So now what's alike on the left and the right side? What do I have that's similar? The sine squared. What do I have that's totally not similar? That cosine squared. Okay, so is there something that I can sub in for cosine squared? Because basically when I compare the left side and the right side, I have only sines, I have no cosines. So is there something I can substitute for cosine squared so I can get rid of it? There's only a very few things that you have for substitution. Yeah, cosine squared is the same thing as 1 minus sine squared. Okay, so let's take out the cosine squared. Let's replace it with the Pythagorean identity 1 minus sine squared. Now I'm not going to keep on writing that 1 out front. When I multiply, I don't need it anymore. So I have sine squared theta minus, so far it's just a copy. In for cosine squared, let's replace that with 1 minus sine squared. Now, did I write that correctly? No, I did not. What's wrong? Yeah, if I write it like that, I haven't distributed my negative. Okay, so you have one of two options. Either distribute the negative or go ahead and just put what was cosine squared, put it in a set of parentheses so that you'll remember to distribute the negative. All right, so now I have sine squared minus 1 plus sine squared. Dylan, what can you do with that? Again, pay attention to the right side. Yeah, combine like terms. Sine squared plus sine squared is 2 sine squared. And now it's the same as the other side. Any questions on that? Okay, so this one looks pretty big, bad, and ugly, doesn't it? So, which side? Take a second and look at the two sides. Which side would you like to start off with? And for the record, I could go with either side. It doesn't matter to me which one you go with. So if you tell me, let's start with the right or let's start with the left, I'm going to ask you why. Okay. So, because I can think of reasons to start with both sides. All right. So which side would you like to start with? What do you think, Marina? And what would you do with the right side? Okay, now, do you only want to change cotangents, Marina? Everything? Okay, I'm fine with that. So let me build my brick wall here. Okay, Natalie, what's the first term on the right rewritten with sines and cosines? Okay, now notice that I've got three terms. So let's look at the middle term. The middle term is negative. That 2, by the way, we're going to have a fraction, right? Because we know that cosecants and cotangents turn into fractions. The 2, I'm just going to go ahead and put it on the top. Okay, so Zykeria, in that middle term, we've taken care of the 2. What about the next piece of that term? The cosecant, what can it be replaced with? 1 over sine. I'm not going to write the 1 over because I've already got a 2 up there and it would be a 2 times a 1 and I don't need that. So I'm just going to write the sine on bottom. And Zykeria, what's the third piece of that? Cosine over sine. So I'm going to put the cosine piece on top. When I put the sine piece on bottom, what is the bottom going to end up turning into? Sine squared. Okay, which is nice because there's a common denominator already that has a sine squared. So it's nice that I've already got a common denominator. All right, now the third term. Okay, I mean, what's the third term going to be? Close. Watch out for this, Yamin. Nope. Go back to the first one that you said, because we are turning into sines and cosines. But you ignored the fact that there's a square here. Very good. Cosine squared over sine squared. And once again, that's nice because all 3 of my fractions have a common denominator. Okay, so what I'm going to do at this point is I'm just going to write all 3 of my fractions and they have a common denominator. So really, I'm not doing any math right now. I'm just copying the line above, but I'm writing it with a common denominator. So I have a 1 minus a 2 cosine of x plus a cosine squared of x. I'm just copying the numerators. Now, what can I do with that? Aaliyah, what are your ideas on that? You're not sure you're stuck? Okay, so what do we do when we're stuck? Go to the other side. It's okay to be stuck. Let's go to the other side. Okay, so what's something that I can do with the other side? Okay, and how do you mean I would use the Pythagorean identity, Selena? I think basically what you're telling me is you sure wish it was a Pythagorean identity, right? But it isn't. So what is it that we can do when we wish it was a Pythagorean identity because it seems so close? What's that magic word? Conjugate. Yeah, we're going to use the conjugate. Now, this is one thing that I did not say last Wednesday. So here's a little tip about conjugates. Because I could do the conjugate on top, I could also do the conjugate on bottom, right? If you're given a choice, like if you come to a question and you could do a conjugate on top and you could also do a conjugate on bottom, choose the one with the bottom. Always choose. Now, sometimes there's not a choice. If it's just a conjugate for the top, then go ahead. But if you've got a choice, choose the one for the conjugate on the bottom. Okay. Now, if that's the case, what are we going to multiply by? What are we going to multiply this whole entire fraction by? 1 minus cosine of x over 1 minus cosine of x. Why is that legal? It's equal to 1. Multiplying by 1 doesn't change things. Okay. Now, look at the denominator. Look at the denominator. When you multiply the denominator, what do you end up with? One minus cosine squared. Is that what you're saying, Aaliyah? It's hard to tell. Okay, 1 minus cosine squared. Hey, wait a second. What's 1 minus cosine squared equal to? Sine squared. That's a Pythagorean identity. And doesn't that kind of make you jump and dance a little bit? Just a little bit? Because the denominators, as soon as I write one of them the other way using Pythagorean identities, I've got my denominators to match. Okay, now I just have to get my numerators to match. Now, look at the numerator that we're trying to go for, which is this guy. What can we do to the numerator over here on the left side to try and make it match the right side? Cecilia, what do you think I can do with that? No guesses? None? What's that? FOIL? Yeah, I mean, it's 2 binomials. Let's multiply them together. So what do you get for the firsts? 1. What do you get for the outers and the inners? Multiply the outers, multiply the inners. What do you get? Were you saying something, Michelle? Yeah, both of them are a minus cosine. So what's a minus cosine minus cosine? Minus 2 cosine. And then what do you get when you multiply the lasts? Cosine times cosine with a negative. So that's going to be what? Sorry, it's a negative times a negative, which is a positive cosine squared. Hey, let's go check that with the other side. Wait, what do you see? They're the same numerator. Okay, so the only thing I have left to do then is take care of matching up the denominators. Our brain knows that they're matched, but we just need to take the extra step and write it down so that the instructor knows that that's what the brain is thinking. It doesn't really matter which side you change. I'll change the left side. So 1 minus 2 cosine plus cosine squared all over sine squared. Any questions on that one? All right, so let's get together in groups of 2. and work through number 15. Work through number 15. Don't just ignore each other and work through it separately. I actually want you talking through this one. By the way, this is a new Greek letter. I think it's, I don't know, does anybody in here know Greek? So I'll sound smart no matter what. I think it's a lambda, I think, but I can't remember, or a gamma. I don't know. I don't know what it is.
Okay, these kids have, right? No, because you're controlling this.
Where is your Greek letter for the numerator? And for the tangent? It's okay, it's good that I can catch those things now, because I do take more points for that on the test.
I would get add them together.
Cosine squared. We would go ahead and go. Yeah. And then let's do the cosine. That would be, oh, you know what, two rectangle secant the same, is that the identity?
All right, so let's take a look. So what did you do first? As I was walking around, almost everybody did the same thing first. Just talk to me about it. What did you do first? Yeah, sines and cosines. All right, so on this first one, we can keep the cosine squared of my lambda or gamma or whatever that thing is, times cosecant squared. What is cosecant squared? 1 over sine squared. Okay, so that just means that it's going to go on the bottom, right? Okay, it's where the cosine squared is allowed to stay on the top. The sine squared, it's a 1 over sine squared, so the sine squared stays on bottom. Plus, so I got, again, a cosine squared. What is secant squared? 1 over cosine squared. And what happens with those two? Oh, good, they cancel. Okay, now for the first term, what is cosine squared over sine squared? Cotangent squared plus 1. Hey, what is cotangent squared plus 1? Cosecant squared.